Hello there. So today what we're going to look at briefly is how to do something called the greatest common factor. And the word common is really important here because when we make our decision what to take out of, for example, these two numbers that you see in front of you, the 12 and the 8, it has to be something that works for both of them, and that's where the word common comes from. Okay, so let's say we have a 12 and we have an 8. What you need to think in your own mind is what number can divide 12 and divide 8? And you can think of some numbers like, 2. 8 can divide by 2, 12 can divide by 2. Is there any other numbers that can divide both of them? Let's try 3. No, that wouldn't work for the 8. Let's try 4. 12 divided by 4 works, and 8 divided by 4, that works. Let's try 5, 6, 7, 8. 8 is as high as we can go because that is the smallest number here. So basically what I'm finding out here is that the 4 is the biggest number that can divide 12 and also divide 8. Okay? So the greatest common factor, or as they say here, the GCF, is 4. I'm just going to show you a little trick in case you had a hard time thinking about it. You can take a graphing calculator or another calculator that can reduce, and what you can do is you can type the two numbers we see right here, the 12 and the 8, write them as a fraction, so 12 over 8. And then I've showed a lot of you in class, but what you can do is you can reduce this fraction very quickly by pushing math and then hitting enter 2 times, 1, 2. Then you get 3 over 2. So what that means is 12 divided by 3 and 8 divided by 2, the answer that you get will be our greatest common factor. So let's do it really quick. 12 divided by 3. Surprise, surprise, that's the same 4 that we came up with over here. And then let's go 8 divided by 2. Well, you don't really need a calculator for that, but here we go. 8 divided by 2 is 4. So there it is. That's our greatest common factor, 4. You don't always need a graphing calculator to help you with that, but I'm just saying in case you want help with that and it's not coming to you, you can do it that technique. So let's try the next one. We have 24 and 12. Well, what numbers can divide 24 and 12? I know 2 works because they're both even numbers, so they can both be divided by 2. 3 works, and that's just because I know this in my head. 12 divided by 3 is 4, 24 divided by 3, it happens to be 8. 4 works. 5 does not work. 6 works. 7 does not work. 8 does not. 9, no. 10, no. 11, no. And 12. 12 works because 12 divided by 12 is 1, and 24 divided by 12 is 2. So there we have it. Our greatest common factor here is 12. That's the largest number that can divide 24 and 12. Now sometimes you get questions that have variables in there, like an x squared, and there's an x over here. So here's what you do. You start by looking at the 3 and the 12, and you say, what's the biggest number that can divide 3 and 12? Well, the answer is 3. And then you look at the x squared and the x there, and you can think of it this way. It's like two people standing at the street, and you say, hey, do you guys have an x to give away? And they would both say, yes, we do. And then you might say, well, do you guys have 2 x's to give away? And this guy would say, sorry, I've only got 1. And this guy over here would say, sure, I've got 2. The problem is this is called greatest common factoring. Yet they have to give away the same amount. So if this guy can only give away 1, that means this guy's only allowed to give 1 as well, even though this guy actually has 2. So you just write down what they can both give away, the most that they can give. And as you can see, it's just an x. So the greatest common factor here is 3x. Okay? Now, where are you going to use this stuff? Well, you could get a question like this. It says factor this expression. Alright, so what you do is you do exactly what we've just done. You get the greatest common factor. So we've got a 6 and a 9 here. What's the biggest number that can divide 6 and 9? Let's think about it. We got 2, no. 3, yes. 4, 5, 6. Okay, 3 is our greatest number that we can take out of these two, because 3 can divide this and this nicely, and it's the biggest number that can do that. As far as the x's go, it's very similar to the problem up above. This guy can give away 1x, this guy could give away 2, but because it's common factoring, we have to put down what they can give, the most that they can give it. And they have to agree on, they're both going to give an x away. Okay, we are factoring this. So what we're going to do is put the greatest common factor outside a bracket, and on the inside of the brackets, we're going to write down what we have left over. So what you do is you take each of these terms, here's one term and here's the other term. Take each of these and divide. That's right, you divide by 3x. So this is the way you do it. 6 divided by 3 is 2. Okay? And if you have 2 x's here, and you divide by 1x, so x squared divided by x, you end up with just an x. Now let's go to the 9. It's a positive 9 and a positive 3 here. So you're going to get a positive answer. So I'm going to write down the plus sign. 9 divided by 3 is 3. X divided by x, well, that's just 1, so I'm not going to actually write that down. I'm just going to finish it off because 1 wouldn't actually change anything here. And here we have it. This is our answer. We have just put this thing, which is in expanded form. This thing here is called expanded form. We have just put it into factored form right here. And the greatest common factor is in the front. Whoops. The greatest common factor is in the front. I've lost my pen. That's weird. It's just messing up on me here. There we go. Greatest common factor is right here in the front. And here's the rest of it. You can do a little check if you want to make sure that you've got the right answer just by going this times this and this times this. That's called expanding. Okay? Let's do it really quick. 3x times 2x is 6x squared. 3x times 3 is 9x. Does that look familiar? Indeed it does. It's got right back to the original expanded form, which is the original question. Okay?